Hello. Hello, am I audible?
Yes, yes, you are.
Okay, so we'll wait for 5 minutes and then we'll start. So the screen is visible. I request you to please unmute yourself because it's a discussion session. So okay, all right. So is the screen visible? Okay. Okay, so I am a PMRF at IIT Kanpur and I have to take this interactive sessions where we will be going to do some practice problems, some numericals that will be going to help you in solving the assignments. And as it's a 2 hour long session, so I will be happy to discuss anything. But as you know, this is the first week. So this is related to the first week lectures content. So it is mostly introductory session. First week is mostly on introduction. So So today is nothing much conceptual also there. So generally what I do is I divided this content into two halves, like some conceptual questions from the lectures and as well as some of the numericals. So depends on the response, we'll go along with the lectures. So before going ahead, can I request you to please introduce yourself once so that it will be better and it will be good for discussion among us. So yeah, Dinesh. Hello. Oh, okay.
Yeah, so hi, I'm Dinesh, and so I'm from Hyderabad. I do some research related to numerical methods, fluid dynamics, CFD, especially I deal with meshless techniques.
So you're a
And
PhD.
yeah, so I have, yeah. So
With
I
whom?
have, no, I got my PhD, so this is just I'm just here to learn some stuff.
Okay.
Yeah. So yeah, so I'm trying to see other fields and it's kind of collides and surfaces. I think this is related to my current project where I'm dealing with if you have suspensions inside kind of a solution or fluid.
Yeah.
Suspensions essentially um, absorb the liquid and it will swell. So there are some I don't know, like, so some colloids in surfaces, that area is also related to this current research. Even though I'm not dealing with colloids in surface exceptionally, I may not, but I think this will somehow help me understand some part of my own research which I'm doing. So right, yeah. So
Okay.
great. So which year are you in, Shreyang, by the way?
So I'm in third year.
Okay, that's
So just
great.
about to complete third year.
Okay, so you're a chemical engineering PhD chair
Yeah,
in
yeah.
Shreyang. Great, great.
You are also from chemical engineering.
No, now I am from chemical. I was from aerospace before.
Okay.
Yeah, but we
So
all do same stuff. So,
with whom you did your PhD?
so I did with Prabhu Ramchandran. I did from IIT Bombay.
Okay.
So I did aerospace, Prabhu Ramchandran. So
Now you're jumping into the field of colloids and suspensions.
actually.
Okay.
Okay.
And okay. Thanks.
Any questions? Yeah. Okay.
Yeah. So Kaushika V. Kaushika V.
Hi, yes, sir.
Yeah. Hi. Can you switch on the camera?
Sir, I can switch on it, but I'm in hostel. Is it okay to switch it on?
Yeah. It's fine. It's just a discussion session. More
Okay,
interactive.
okay.
Just a moment, Koshki, just give me a minute. Because you're recording this, will this be online somewhere? Because I
Yeah,
don't
it will
know. So
be
that's
online. No, but I have to
edit it.
uh, it will be online. It will definitely be online. But I have to cut the content
Yeah,
only.
probably try to do that.
Yeah,
Yeah. Okay. Great.
yeah. I will take care of it. Yeah, Kaushika.
Hello, sir. I'm
Yeah.
Kaushika. I'm doing my PhD in VIT Vellore.
Okay.
Actually, my kind of research is synthesizing magnetic nanoparticle for hyperthermia application. Actually, I'm focusing mostly on the fluid nature. So my senior actually suggested me this course because she completed this course. So she asked me to read this part because she told that it will be more useful for my future research. So I thought just joined in this. I don't know much aware of it because I'm from a physics background, but I'm learning it little by little.
Okay.
Thank you.
Thank you. Taruni.
Good evening, sir.
Hi. Hi.
I am Taruni. I am studying third year BTech, sir. I'm from Andhra Pradesh, JNQ College.
Okay. Nice. Nikita.
Yeah, hi. I'm Nikita and I am doing my PhD from IIT Hyderabad. So mainly I'm working on colloidal gels right now. So
With
that's why
whom you are
I'm
working?
Dr. Mahesh Ganeshan.
Okay.
And also I have co-guide Dr. Alan and also Dr. Ranjit Mondal, maybe you know him.
Yeah. So uh, he is it's his supervisor's course actually.
Yeah, exactly.
Okay. So Pawan.
Hi, Rayank. This is Pawan. I'm a PhD student at McGill University, Canada. So yeah,
Which
and
university?
McGill,
Okay.
McGill, Canada. So basically, I'm doing this course because I just wanted to get some knowledge on the surface interactions between nanoparticles. So basically, I'm doing my research on biologically inspired design,
Okay.
which is kind of getting inspiration from biological sources and designing new stuff. So I really wanted to expand my knowledge on this kind of nanoparticle interactions where you find in the surface interactions between these nanoparticles. So this is what I'm looking for. Yeah.
Okay. Nice. So it's all done, I think. All on. So as I already told you, all the discussion hours from the next discussion hour, I will be going to divide this discussion hour into two parts. First is the conceptual questions based on the lectures. Some fundamental that will cover some of the fundamental aspects as mostly theoretical, and as well as second part of it will consist of the some numericals related to the lecture or some derivation, something like that. But as far as I know that I have also gone through the first part of the first week's lecture. So it is most of the introductory part. So only the last lecture or just the second last lecture having some numericals related to the characterization of the colloidal particles. So I will be going to discuss some of the related some of the related numericals on that. Apart from that, I wanted to know if you wanted to discuss anything from the lecture. So we'll discuss it first, and then I will briefly go through all the lectures. So I will be giving you a brief summary, and then we'll cover those numericals for the first time session. So if you wanted to discuss anything specific, you please let me know, and then we go ahead. So you maybe you have some issues or some doubts in your mind with those lectures. If you wanted to ask, maybe I will try to answer. Anyone?
Yeah, like I did not attend all the lectures, only first and second I was able to. So
Okay.
if you can just brief us about few concepts and then go to numerical questions, it will be better.
Okay. Anyone else? Okay. So I will be going to summarize the lectures. So first, so basically, sir has started the lecture with, so basically as the name suggests, the course is on colloids. And I am also a student, so please, you can try to understand that if you have any question, you can ask freely. We will discuss it, and if I am unable to answer, I will go back and read and will tell you that if I am unable to tell you at the moment. And I also request you to keep your mic unmute so that uh, it it will be a good interaction. So as the courses on colloids and surfaces. So in the first week lecture, it's mostly the discussion is mostly on colloids. So what are colloids? So colloids, as discussed by sir, is any particle so So any particle which has having a size having a size range from 10 to the power 9 meter to 10 to the power minus 6 meter, which means that 1 nanometer to 1 micrometer, and that particle is considered to be a colloidal particle. Now, after that, there is a discussion on dispersion, colloidal dispersion. The colloidal dispersion is having two phases, that is dispersion medium and colloidal particles. So basically, it is in generic divided into two phases, that is dispersed and continuous phase. Okay, so dispersion is a so as I already said, a dispersion is a homogeneous mixture consists of colloidal particle dispersed in a liquid media. So that is colloidal dispersion, and the important point to note is that the mixture is homogeneous only at macroscopic level. So the dispersion is homogeneous at macroscopic level. Macroscopic level means to say that at continuum level. Yeah, any doubt, Pawan?
No, there's no doubt here. I just got it.
Okay. So if I have to draw the figure and say, so I'm just summarizing the lecture content, nothing new till now, at least for the first. So these are the colloidal particles inside so this is a media. So that is the continuous media, and these are the colloidal particles, and that is the colloidal dispersion. Okay, so there are some of the examples that sir has discussed. So the continuous as the on the basis of that are characterized or that are differentiate on the basis of continuous phase and the dispersed phase. So the continuous phase are So if it is gas, now I will be going to interact with you in this. So if gas is the continuous phase and dispersed phase is, let's say, liquid. So can you tell the example of it? Just by thinking, not however it is written somewhere, but just by thinking. So liquid is a dispersed phase where gas is a continuous phase. So it's a container where there is a gas and
Whipped cream, right? Whipped cream and things like that.
yeah. No. In whipped cream,
Liquid is the continuous phase and gas is the colloidal phase, right? I mean, the gas is the colloidal particle.
yeah, it's a vice versa thing that you are saying.
Okay, yes, yeah.
Yeah, so it's not a whipped cream. Anyone else?
Aerosols, maybe some kind of aerosol.
Yeah, aerosols are there, but what kind? If I say dust, do you agree with it?
No, because dust is the dispersed phase would be solid particles, right?
Yeah. That is correct, aerosol, but which kind of aerosol? If it's solid, then it is also aerosol. But there are many different kinds of aerosol where both the possibilities are there. Anyone else? Dinesh?
I think fog might be a example
Yeah,
of
correct.
gas liquid.
Fog is the example of it.
Yeah.
Anything, smog is also like that only. Some smog. Can we say dew in the atmosphere? I'm just asking.
Might be, yes, of course. But I think the particles are not at nanoscale, right? So I don't know, maybe if we
It
can
is not
call
a
dew
particle,
as
it's a molecule, droplets of water.
yeah.
And also, when you use perfume insect, like when you spray the perfume, kind of mixture also can be considered as, right?
So I don't know the exact size of
Oh,
the,
size.
because it's the
Okay.
droplets.
Yeah. Okay. So they need
Size
to be.
matters
Is it?
at nanoscale. At least one dimension must be at nano level, right? So that's what.
Yeah, the main thing is that the dispersed phase should be in the range of nanometer to micrometer. That is the main thing that we have discussed, like what
Okay.
colloids
No,
is.
that is not considered.
Hmm.
Yeah. Sorry.
So I don't know, but so these are the more generic examples that you know in general, where you know. So if you are saying, so Pawan has already given example of what you say, smoke.
Yeah, fog, smog, and
It is
Dust.
also.
yeah, we are discussing about dew, right? So dew, the particles in dew, I don't think so. They are at nanoscale. So that's the only concern. That's all.
Yeah. So solids in aerosol are just the normal that the pollutions that is due to the some smoke, smoky air where there is a smoke. That is the example of smoke dust.
Yeah, smoke.
Okay. So now let's take solid as a continuous phase. So we can go by order. So gas, liquid, and solid. So in liquid, there are three possibilities. Liquid, solid, and gas. So you are working on, Dinesh, you are working on something like this, liquid.
Yeah.
So that is,
But my particle size is quite big. So,
okay.
anyways, yeah, I don't know how it actually how I can relate to my research.
So these are the emulsions. And it's like milk or some of the creams that are present in the market, some body lotions,
Okay.
something like that. Solid and liquid.
Well, typical
can be
fluid
some-
as best.
What?
Yeah, Pawan. Sorry. Yeah, Pawan.
Yeah, it can be paint, right? Paints,
Yeah,
any kind
paint.
of paint. Yeah.
Correct. So these
So here,
are
what you're saying
called
is
as,
the solid particle has to be nanometer size. Is that what you're
Yeah.
trying to say?
yeah, in the range of a nanometer to micrometer.
Okay. So the paint inside, like if you have lipstick liquid phase, the paint is at the size of nanometers. Is that what it is? Because I don't know how actually
No,
paint
paint
is.
is having some particles, some solid particles that are in the range of nanometers.
Okay. All right.
And gas and liquid. So Pawan already said,
This
give
it
an
was
example. Whipped
yeah,
cream.
whipped cream, and maybe this leather from the soap,
Yeah,
things like that. Yeah.
Excuse me, sir.
Yeah.
You said about paint.
yeah.
No, can we consider nail polish because it's also in a fluid form? Is it in liquid and solid, or what is
I think
the
nail
type?
polish will also come under solid and liquid. So solid as a dispersed phase and liquid as a continuous phase.
Okay, thank you.
Any kind of ink material that is giving you color. These colors are because of the colloidal particles mostly. So like ink, like the ink you use in your printer, that is also a colloidal particle. That is also a solid and liquid, and similar other things also. So anything that related to this coloring substance comes under this solid and liquid. Solid as a dispersed phase and liquid as a continuous phase. Okay. So gas and liquid is all the examples are there. So it's basically called as foam. So now we have solid as continuous phase and gas. All the possibilities are there. Gas, liquid, and solid. These are some of the rare things, but we see all these things in our daily lives. So can you think of something like solid as having a continuous phase and gas is inside it as a dispersed phase? Anyone? Pawan?
I'm thinking about cellular structures because cellular structures they have some kind of foam, right? Like foam-like structure,
Porous media.
which is
Porous
like
media. Like
Yeah,
you
yeah,
yeah,
have
porous
porous
media.
media.
All
Yeah,
the porous media are like that only.
like the
And
sponge, right? Like the sponge, I guess, most
Yeah, yeah.
probably. But the sponge, the air gaps are quite large. But you can think about like that. So solid in air.
But if I think any porous media will come into that, air gaps are quite large, but the air molecules, if you see, there are a large number of so the dense. If you see that, like there is a specific when we are saying colloidal dispersion, so we are specifying that the colloidal particle are of a particular size, but number of we are not particular, not we are not very particular about the number of colloidal particles present in the system. Obviously, it is less than that of the continuous phase, but
yeah.
So that's why any porous media comes under to this
So
gas and
I'm not sure like what research areas you guys are into. So, do you do numerical modeling, Shreya? By the way?
yeah.
So my question is, so whatever the water present inside a solid body, let us say that we're dealing with the third one. Do you think can we consider that as continuum, the fluid or whatever the minimal phase? Can we consider that as a continuum? Because we discussed that it has to be nanometer range. So once the other phase is in that range, can we model it assuming it as continuum? Like does it follow continuous? Continuing formulation. Just if you understand what I mean.
like you are saying that so you are having some porous
Can
media.
we use like Navier-Stokes, say that you have water inside solid? Can you use Navier-Stokes to understand the dynamics of such phase? You understand?
For the case of porous media, what I know is up to my knowledge, it's Darcy law that we generally use.
Okay. Is
Uh,
that still
model.
different? Okay.
But if you what you are saying, like you are just saying that if we are having a solid that is having a pores inside that and fluid is flowing into that, so
Yeah.
can we consider that fluid as a continuous media?
Continuum, exactly. Huh.
Yeah, but I think I have seen that people are using that as a continuum media, that fluid inside that porous media.
Okay.
I have also seen in like this uh, viscous viscous fingering instability where I'm not sure about exactly. I don't know exactly what it is, but I've seen that people are considering this fluid that is going through the pores as a continuum, as a continuum media.
Okay. So something interesting to think about. I will look into it.
Yeah. So gas and solid is any porous media. Some of the pressured powders is one of the and there are many examples. Now liquid and solid. We used to eat a lot. Liquid and solid. Any guesses? Any guesses about it? Koshika?
Sir, jelly, candy jelly. We will
Yeah,
have.
can be jelly. Yeah, jelly is one of the example. Anything? Koshika?
I'm thinking of that. I'm not
We used to eat a lot. Rashmi?
sure. Sir,
Rashmi.
I can't hear you.
Are you telling me, chewing gum?
Which?
Chewing gum? Bubble gum?
No, I don't agree with chewing gum because is there solid only? There is nothing.
Okay.
nothing
I'm
else.
thinking. Yeah.
Pawan?
Yes, I just saw the example from the internet. So it says butter.
Yeah, butter. Butter. That's why I'm saying that we used to eat a lot. So that is butter.
Okay.
Jelly is also one of the example. Any other example you found?
Just
So that is butter.
yeah, kind of blood pigmented ink.
jelly,
Yeah.
and solid in solid emulsion. Sorry, solid in solid something. Have you heard? Have you seen? It is very rare to understand. Solid, solid. So concrete is one of the example. So then after this, sir has discussed the different terminologies and the differences between all these terminologies. So so some of the terminologies that are discussed are dispersal, suspension, and solution. So dispersion we used to say, so when we are saying dispersion, these are all the terminologies are look similar, but there's a difference. So dispersion I already told, when the colloidal particles in a continuous media is order of the range of nanometer to micrometer. So then we say dispersed. So when the dispersed particle is of range from 1 nanometer to 1 micrometer in a continuous media. Suspension is we call suspension when the size of dispersed particle is greater than micrometer, 1 micrometer. So that is called suspension. And solution is the molecular mixture. So in the case of solution, the both the phases are of comparable range. So size of both the phases are of comparable range and less than of millimeter. So these are the terminologies that are introduced in the lecture. After that, so any doubt till now?
Excuse me, sir.
Yeah.
Sir, do you heard about plasma, the fluid in the blood?
The fluid in the,
The blood, the plasma.
yeah, I have heard it.
So which comes under which category, sir? Liquid in liquid or liquid in solid? Because it consists of different types of protein into that.
Plasma. Uh, can you tell me which kind of plasma you are talking of?
Sir, the plasma which is present in blood.
But what is the properties like? What is the solid and what is the can you tell it in terms of phases? Dispersion.
Sir, actually plasma, it is in a fluid form, but it consists of some kind of protein or lipids. I am not sure. I have not don't have a idea of much idea of that. but I heard about that part. Blood, serum, plasma. Those are in liquid form, but it consists of, but it's a colloidal in nature. That's how I know. So I don't know which phase of state that is.
So so you will we're going to give its answer. So my question is the lipid is solid or liquid?
So liquid. It's a liquid only.
What?
Lipids. You are asking lipid.
Yeah, lipids. If it's a lipids in a plasma, then is it solid or liquid?
So actually, that I don't know. It's consist of many things. No lipids, protein. That's why
But lipids and proteins, is it solid or liquid?
it's look like a liquid in nature. I don't know that. I know that plasma is a colloidal in form. So I know only that part. Plasma is a colloidal in form. So
Yeah, but when you are saying protein or lipids in a plasma, so plasma has having a continuous phase that is uh liquid, and other thing is whatever you are saying, lipids or proteins. These are solid in nature.
okay,
So it's a solid and liquid. So that will come into the category of uh some this kind of thing, paints or some plasmas, I guess.
okay.
I'm just uh coming out with, I don't know what exactly it is, but from the point of view we know, like we can always try to find out. So that's why this discussion is there. So you have to identify what is the continuous phase and what is the dispersed phase. So now from your what you told me, we are able to identify that the continuous phase is liquid and the dispersed phase is some solid, because are you agree on that lipid is a solid?
Actually, that's what I'm telling. I don't know about that part. I just know it's a colloidal in nature. That's it. I have not much idea of that. That's why I'm asking to you. If you know, you can
So
say.
okay, so the lipids are solid, so that's why uh so it's a solid in liquid.
Okay, thank you.
Pawan is there. Pawan, you are working on something biology, so you know what lipid is? Actually, I don't.
Yeah. Lipids are solids actually. Yes,
Lipid.
of course.
Yeah.
Yeah.
So then it is fine.
Yeah.
Okay. So now we come on to the classification of colloids. So there are classification based on the so we have time. Okay. The classification of colloids can be based on the uh, interaction between the dispersion phase and the dispersion media. Okay. So dispersion medium, saying it's a continuous media. That is so just don't want to confuse. So this continuous phase is the dispersion media. Okay. So classification of colloids on the basis of the interaction of dispersed phase and dispersion media. So if both are liking each other, if dispersed phase like dispersion media, then it is lyophilic. Philic dispersons, lyophilic colloids. if they hate each other, then they are lyophobic colloids. And lyophilic colloids are mostly stable in nature because they like each other. So there is some way of stability there. So when you form a colloidal dispersion, so if you talk in terms of thermodynamics, so the energy will decrease if they both like each other. If they both hate each other, then there will be an increase in energy, and that will leads to the thermodynamic unstable colloidal dispersions. Uh, then there is a, so this is the discussion based on the interaction of dispersed phase and the dispersion media. Then there is a discussion that is based on any question in this till now. I'm just summarizing what sir did. So there are other kinds of colloids that are multimolecular colloid. So the example of multimolecular colloid are a dispersion of solid particle that we have discussed. In liquid, then we have macromolecular colloids. So this is the dispersion of polymers. In solvent or some liquid or dispersion media. And then we have association colloids. So that is the dispersion of aggregate colloidal particle in a media. Okay, so these are some of the classification of colloids. Then there is a discussion on stability in colloids. So if the colloids are stable, you will see that if there is a media that is like this.
I have a small doubt.
Yeah.
If we consider block of polymers, so will it come under macromolecular or associated colloid?
Blocks of the blocks means you are having a
Like bipolymer or tripolymer, something like that.
so it's the aggregation. Is it the can we say it's the aggregation?
Okay.
Yeah, if it's a normal polymer chain, then it's definitely comes under the macromolecule. If it's a block, then what do you think? Any idea, others? Others can also answer it. According to me, it's the association colloids because it's a block of the polymers, not a single polymer, not of just the dilute polymer solutions. It's a block of the polymers. Are you agree with that, Nikita?
Yeah, but I was having a little confusion in that. Like polymer, you have mentioned dispersion of polymer means like which type, which kind of polymer?
So which kind of so the polymers are of just the polymeric chains.
Polymeric chains. So chain means again it will be a combination of one or two or more polymer.
Uh, but when I'm saying polymeric chains, the main thing is to say that it has having a large molecular weight.
Okay. Okay, let's continue.
So when you are saying a block of polymers, so I'm not from polymer background, so but I wanted to discontinue this discussion on it. So if you are having a block of polymers, and what is the difference between just one chain of polymer?
So even I am not from polymer, but in the first lecture, I guess was saying something on block of polymers, like two different types of polymers are getting attached. By discussing few examples on colloids, like motivation behind that. Let's discussing that.
So what did so they said about this polymers in the dispersion media is considered to be a macromolecular colloids because these are having a high molecular weight.
No, he did not discuss anything about this
Molecular weight.
classification, but he was just giving like motivation behind this, studying these things. That time he was saying something. Okay, I will look into that.
But I think mostly it's so if it's a block of if 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 it is a let me correct my words. So if it is a association of a large number of polymers, then it comes under the category of association colloids. Otherwise, it's a normal macromolecular colloids.
Then it may be association.
What
Yeah,
is it clear?
then it should be association colloids only.
Yeah. And if I found anything wrong in my statement, then I will clarify it and we'll discuss in the next class. Okay. So now, any question apart from it? Others? No questions. Okay, so let's quickly move ahead. So there is a we have to discuss the stability in colloids. So we are having a dispersed phase and a dispersion media. So if if the colloidal dispersion is stable, then it's like this. So that we have so it's a sort of lyophilic where they like each other. So the interaction between the two particles is less than that of the particle with that of the molecules of the dispersion media. While if you see this kind of configuration where there is particles comes together after some time and they form some aggregation, then it becomes unstable. So that it becomes unstable. So sir has discussed this plot of kinetically stable and unstable. So what he has discussed is this. So there is a plot something like this where so there is an energy barrier. So when the two colloidal particles, so it's the distance between the colloidal particles, distance between colloidal particles, and this is some type of energy scale with kBt. So if the two molecules come together, and if delta E, so when the two molecules comes together, so the change in energy is delta E, and if it is uh, greater than kBt, means to say that they are unable to cross this energy barrier. This energy barrier is very high. This energy barrier is basically, so this energy barrier is very high, so that is delta E. If it is very higher than kBt, then it is stable. It is kinetically stable colloid, and vice versa is true for unstable colloids. Okay, so any questions on it? Any questions? So this is about the stability. Then he talks about the, yeah, Nikita.
Change this energy, how this change comes from where this change comes from, this energy
I'm unable to listen. Can you speak a bit louder?
Hello?
Hello. Can you write it in the chat box? Hello, Nikita. So the energy barrier is defined mm, by the interaction of the two molecules. So when the two molecules, so there is a so there is some distance. So there that is the distance that is there, and so it is the inherent property of the interaction. So it is how the so your question is mostly dependent on. So my answer is it is mostly dependent upon the interaction between the two colloidal particles. So when they try to come closer, if the energy, so the energy barrier is higher. So that energy barrier is the property of the how they are interacting. If it is weak, uh, then energy barrier is if the interaction between the two colloids is weak, then energy barrier is less compared to that of kBt. That is their kinetic energies. And if it is high, if they are having a strong interaction between the two, then the energy barrier is vice versa true for it. So that depends on the interaction between the two colloids, the energy barrier. Hello, Nikita, is it fine? Did you get it? Okay, if we add salt to the continuous media, then it becomes stable. So the concentration of salt as well. My answer to that is that when we add some salt in the continuous media, then when so the interaction between the two colloidal particles will get affected because of the addition of some salts. And so there is some hindrance in between the interaction, which is going to affecting this stability. So when we add some when we add some salt, so there is so energy barrier will get decreased and they are able to come together. So the so the dispersion is basically it gets unstable, and there is some kind of aggregation. Any more question on it? Hello, Nikita. Hello, Nikita. Am I audible?
So I'm saying that so you're trying to say that it depends on concentration of salt as well. The energy barrier depends on concentration. The continuous phase.
The energy barrier, you are saying that the energy barrier depends on the concentration of the salt solution.
Yeah.
Okay, but like when we are having a salt there, so then there is a if you see that like NaCl in a some salt is there, so the because you are saying dispersion media as one of the salt solution, right?
Yes.
So then this dispersion media is already having some particles inside that. So that is which is going to affect this interaction between the two particles. It is if it is there is no salts present. It is if it is a clean water, like some millipore water it is, then whatever the interaction between the colloidal particles and the particles between the uh, particles with that of the molecules of the media is actually uh, uh, is actually pure, and that is not affected by anything. Can you give so can you give one example where there is a colloidal solution and having a dispersion medium as a salt solution? Because I am sort of confused with like you are having a salt, so that is already having some particles. Some salt particles are there. Some like if NaCl in water you put, so there are NaCl particles are there. Salt particles are already there. but you are now considering it as one of the media, right?
Yeah, I'm considering it as a media. Like if we use stabilizer, it helps that colloidal particle to be separated. So similarly, if we add some salt, it helps to aggregate that particles. So this you are saying that this energy barrier depends on the interaction between the particles. So when we are adding some salt, it easily aggregates. So I'm trying to say that then this energy should also be dependent on this concentration of this salt.
Uh, this energy barrier, actually the energy barrier will remain same because it is only dependent upon the interaction of the two particles. But what the thing that is going to change is the KBT, that the kinetic energy of those colloidal particle in the solution. So due to this, they are able to overcome the high barrier also. Whatever the barrier it is, if you see, so if KBT is much higher, the kinetic energy of the particles is much higher, then they are able to cross that energy barrier. And while crossing that energy barrier, they can easily come closer, and then it makes it unstable. The
Okay, I understood.
barrier is not going to affect by the concentration because it is just the energy between the two pure colloidal interactions.
Okay, I understood.
Did you get it?
Yeah,
Agreeing
thank
on
you.
it?
Yeah, thank you.
Okay. Okay, so this is about this kinetic stability of the colloidal solution. Then sir has discussed some of the characterization of colloidal dispersion. So that is based on the particle size and shape, particle density, specific surface area. So these all things you can go through the lectures once again if you are having doubt. But now it's the time to discuss some of the question because I wanted to give you some time to solve this question. So the first question is like find out the value of C, some constant, some constant, such that surface area per unit mass of particle density rho is given by AM is C by rho into characteristic length. So where L is some characteristic length, AM is specific surface area, and we need to find what is the value of C. So, and we have different kind of geometries. So first we need to find for a sphere. So options are 1, 2, 3, 4, if the shape of the colloidal particle, so that is the shape of colloidal particle. If it is, let's say, disk, in disk, options are 0.5, 2, 3, 4, and also the characteristic length I have to solve by, that is R, 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 R. So I'm saying about what is the value of C by LC. So R here is the radius and H is height. Then third part is long rod. So we have option A, that is B, D, then we have okay, let's take these three parts. So these are three parts. You have to choose the correct option. You have to solve it and let me know the correct option. So let's try this, and I will be going to wait for the till the first answer. Are you solving it, Pawan? Nikita?
Yeah.
Are you able to understand the question? If you have any doubt in the question, then please let me know. Koshika, Rashmi, Dinesh.
Yes, sir. We are also doing. I'm also doing.
Okay. Just try it and let me know. Then we'll discuss it. If you have any doubt in the question, you may ask. You need to find out the value of C by LC.
Is it for the sphere? It is 3 by r, right? I think the option is C, I guess.
Hello. Dinesh, are you able to solve the first? Kaushika? Nikita?
Here, I'm trying it for 3 days.
Okay. Rashmi? Okay, let me try it for the first one. So you may get the idea and we'll try for others too. So for the A part, we have, so we want to find the specific surface area. The specific surface area is, what do you think is specific surface area? What's the definition? Pawan, how did you solve it?
Yeah, I took this surface area of the particle by mass of the particle gives the specific surface area, right?
Surface area of the particle
By mass of the particle.
by mass of particle. Now the question is, from where did you get the mass of particle?
So we do it by using this rho p into Vp, right? So rho p is the density of the particle and the Vp is the volume of the particle.
Yeah, it's rho into volume of
Volume.
the particle.
Yeah.
So it comes out to be 3 by rho r. What about second? Pawan,
Yeah, I just not solve it. I just went back to some works of I not so
okay. Others, Dinesh, are you able to solve it? Any doubt in this? I hope from this you will be able to solve it. Other two. And the hint to thin disk is, uh, if let's say r is the radius of the disk and h is the height of the disk, then radius is taken to be much greater than that of height because it's a thin disk. So okay, just try it with me because we need to try other questions also. So what is the surface area of the particle for the case of disk? Kaushika? If it is the shape of the particle is in the shape of thin disk, then what its surface area?
Sir, I don't know, sir.
Okay, Rashmi. Just imagine this is a disk. And so it
4
is the
pi
form
r
of
square.
cylinder. It is a form of cylinder. What? Pi?
4 pi r square.
4 pi r square.
2 pi r square.
2 pi r square.
2 pi. Only 2 pi r square? Have you employed this or before employing this you are saying?
After employing.
What?
After employing
So can you tell me without this?
2 pi r square h.
2 pi r square h. This. Hello?
Like 2 pi r h, 2 pi r h plus 2 pi r square.
No, I'm not getting it. 2 pi
RH
RH plus
plus 2 pi r square.
2 pi r square. Okay, so that is correct. Divided by rho as usual. And what is the density? Pi
Pi r square h.
pi r square h. Now we are employing this r is greater than h. So if you see 2 pi r plus h divided by rho into pi r square h. We know r is greater than h, so we can neglect h here. So what it comes to pi r square divided by pi r square h into rho. So what it comes is 2 by rho h. So what is it? It is this. Now it is simple for long rod. So if it is a long rod, then again there will be some assumption. But opposite to this, what is that? If it is
R
this
is
is
much-
right, so what?
No, I'm just saying R is much smaller than H. So yeah.
Correct. So this will come out to be. Rashmi, are you able to follow it? Rashmi and Kaushika.
Yes, sir. Yes, sir.
Okay, so tell me the area now. Surface area.
2 pi r h.
What? 2 pi?
H.
2 pi r h. That's it.
Yeah.
Okay. So you are saying after employing it or without employing this assumption?
Employing.
Okay. So that is rho into again pi r square h, and that comes out to be 2 by rho r. That is. So just a homework thing. Try it if it is a rectangle. If the particle is of the shape of cube. Or some rectangular cuboid where it is A, it is B. Okay, so and tell me the answer in the next class. Okay, so this is one of the question. Now another question is, anyone has any doubt in this question, the last question? Rashmi? Rashmi, are you here?
Yes, sir, I'm there. There is some background noise.
So are you able to solve it? Are you able to understand it?
Yes, sir, I've noted it down. I'll go through it once.
You are able to follow that or not?
Yes, sir, I'm able to follow.
Okay, Dinesh? Kaushika?
Yes, sir. So can you explain what is the homework?
No, just take some cuboid. So that is one length is A and another is B.
Okay, sir.
To consider height as well, like 3 dimension. Is it negligible?
What?
We need three dimension.
Yeah, it's a three
Consider.
dimension. Yeah.
Height we need to consider, right?
What?
Height or length.
Yeah, it's a cuboid. It's a cuboid. So I am telling you one. So for your simplicity, B should be greater than A. So it is like this.
Yeah.
Something like this.
So there should be like 3 parameters, A, B, and C.
So this is B. This is A. This is A.
Okay, that is also A. Okay.
Okay. Okay, so the next question is consider a spherical particle of 0.2 micrometer diameter. These particles are functionalized with carboxyl group if the number of carboxyl group per particle is pi into 10 to the power 5. Then calculate the surface charge density. So it's a sort of subjective question. You have to tell me the answer. So try this. And so this is already discussed in the lecture, how to find out all these things, surface charge density. So for your simplicity, surface charge density is nothing but charge, total charge per unit area of colloidal particle. Okay. So try this, and I will be waiting to listen your answers, and then we'll solve together. There is no doubt in the question. There is any doubt in the question? Is there any doubt in the question? Are you able to get the question? Nikita? Pawan?
Yeah, no doubt, no doubt.
Nikita?
No doubt.
Okay. Kaushika and Rashmi?
No doubt, sir.
Dinesh? Okay, just try it and let me know.
Total charge of particles increase. Total charge of particles increase.
There are some answers, so we'll try it. Okay. So Can you help me in solving this question? Kaushika?
Yes, sir.
So can you help me in solving this question?
Sir,
Total charges. Uh,
so for me, it's coming 5 into 10 to the power 5.
yeah, we'll check it. Can you just help me?
Okay.
The total charge is, what is the total charge?
Sir, here it is pi into 10 to the power 5 into,
Into
I think we have to multiply it by 0.2 by
0.2. Why?
2, I guess, because it's a diameter. I don't know. I did it in that way, but I am not sure it is correct or not.
Okay, Nikita?
I think it is like into 1 because carboxylic charge we take negatively charged.
Yeah, but what about it should be in coulombs, no? So you need to multiply it with 1.6 into 10 to the power minus 19 coulombs. Okay. And then surface area, just the simple thing. That is 4 pi r square. Is it the way, Pawan, you have attempted this question?
Yes, I did a little bit mistake in multiplying 1.6. So that's where I got it.
You also didn't
Little bit
multiply it with
mistake.
this?
Yeah, I also, because I think it's pi, it's the carboxyl group into E, right? So I'd not multiply with E. E is the total charge. So I'd not do that. Yeah.
Okay. So that is pi. So because one electron doesn't mean anything, it should be some charge that is of coulombs.
Exactly. 1 electron doesn't mean, yeah.
So 10 to the power 5 into 1.6 divided by 4 into r. So it's 0.2 into 0.2 into 10 to the power minus 12. And this is 10 to the power minus 19. This will go. This will become 10. So something 4.
It's 0.1, right? So this is R, so it should be 0.1, I guess.
13, 18. Yeah, it's 0.1 coulomb per meter square. Okay. Okay. Did you get that? Others? Rashmi? Dinesh? So we'll have one last question for the day, and that
Sir,
will all. Yeah.
sir, here you have put 0.2 into 0.2 means we have to convert the diameter into radius, right?
Oh,
What?
okay, okay. Sorry, sorry.
Yes,
Yeah,
yes.
correct. So that
That's
4
that's the
shouldn't be
thing.
there.
Yeah.
Yeah, correct. So this R is there, so 4 shouldn't be there. So 4 should be there. So that will be 0.4. I think. Is it correct? Yeah.
So how come in the denominator 10 to the power minus 12?
So that is
Because of
Because
micrometer, because of
yeah,
micro.
yeah.
Okay. Okay.
Any question? Is it correct now? Okay. Nikita,
Yes, it's fine.
Rashmi,
Yes, sir.
Dinesh. Okay. So just last question for the day. So that is mineral oxide. These all the questions will help you in solving the assignment. a mineral oxide of density 2.8 gram per centimeter cube is broken into colloidal size particle using ball mill. Calculate the total surface area of the crust material crushed material in meter square per gram when average particle radius is 5 into 10 to the power minus 4 centimeter. Options are 0.21 gram, meter square per gram, 2.1 meter square per gram, 4.2 meter square per gram, 0.42 meter square per gram. That's the last question. Try this quickly and we'll wrap up the session. Any doubt in the question? Any doubt in the question? Pavan, Rashmi, Nikita, Kaushika,
Sir, no, sir. I'm trying.
okay. Hello. Any answers? Pawan?
Just a second. Just a second.
Okay. Nikita? Kaushika?
No, sir. Trying.
Nikita? Hello? Did you get it?
No, no.
Rashmi?
Is it
No,
something
sir,
like
not yet.
is it something like 2.1 meter square per gram, right? Or
Something is like any option?
yeah, no, sorry. I mean, I
According
think
to
it's
the result,
2.14. I got.
Okay, let's try this. So how you are attempting the solution? Can you
6 by rho p into dp is the thing, right? So
6 by rupee? Just go by step, no? Why?
yes. So it's basically the
So if
specific
it is if the
surface area, right?
density is 2.8 gram per centimeter cube.
Hmm.
So per gram, we are having number of particles, that is, sorry, the weight of the volume of particle in 1 gram of mineral oxide is 1 by 2.8, correct?
Yeah, yeah.
Centimeter cube. So number of particles are total number of particles are, we already did. So the volume of, so 1 by 2.8 centimeter cube in 1 gram, that is the total volume divided by the volume of particle.
Exactly.
So that is the total number of particles.
Yeah.
This will be going to help to solve your assignment. Now we need to find total area. Okay, so the total area is number of particle into area of one particle. Correct?
Yes.
So that is 1 by 2.8 into 4 by 3 pi r cube into 4 pi r square. So it will give me 3 by 2.8 r. Correct? So that comes out to be, so it is all going per gram.
Hmm.
2.8 into 5 into 10 to the power minus 4. That is in centimeter. So that is 10 to the power minus 2 meter. So that is all going in. So that comes out to be meter square per gram. Okay. So 3 divided by 5 into 2.8 into 10 to the power minus 6. Is it? I'm making any mistake. It's centimeter. We need in meter. We need this R to be in meters. That is the correct conversion, right? Bhavan, anything wrong?
Yeah. No. I think I did till here. Yes. Yeah.
So can you solve it?
It's basically 2.1, right? Like
Is it 2.1 or 0.21?
I think it's 0.21. So 0.21.
Did we do anything? It's
I'm just checking the conversions with meter square and centimeter square. So
that's all correct.
While solving for number of particles, we took 1 by 2.8 centimeter cube. We should write in meter cube.
What?
Number of particles we should write as 1 by 2.8 into 10 power minus 2 cube. We need to convert it in meters.
No, but we didn't put anything, right? We are doing everything in terms of R.
yeah, R is also in centimeters, so I don't think there is a mistake there.
It's area actually. So yeah, we can try this. So if you are saying it is centimeter cube, then it should be 1 by 2.8 into 10 to the power minus 6 meter cube, right? So that is meter cube. So now number of particles are so if it is R in, oh, correct. Now we got the mistake. So 10 to the minus 6 should be here. We need to put it here only, like it's better to put the value of R here. So that is in centimeter. So that will become out 5. But yeah, so 10 to the minus 4 cube. So that is centimeter cube. And that is centimeters. Wait 1 minute. I think there is some. So that is 10 to the power. No, but this is meter cube. This is, let's keep it meter cube. Let's say we don't know R, so that is R cube. So that is centimeter, that is some cube, let's meter cube. We will put everything in meter later. And this is 10 to the minus 6. 10 to the minus 6. This area is also in meter square. So that is all into 10 to the minus 6 into 10 to the minus 6. And we put this in meter. So that comes out to be meter square per gram. So into 10 to the minus 6. So it is coming out to be 0.21
Yeah.
meter
Right.
square per gram. Correct. Okay.
Yeah.
So the correct option is this. So okay, so let's wrap up this session. So if you have any suggestions to on it, that how to go along, any changes you wanted me to do, then please let me know. And I hope you will be going to come in all the sessions later onwards.
Could you extend the assignment deadline if possible?
It's already, I guess, 8 September. 8 September.
September. Oh, I thought it as August. Okay.
1 minute, check it. We can assign it. So the deadline is 9th of October. Due date is 9th of October, 9/8/2023.
Okay,
I am
then-
able to see the deadline is 9/8/2023.
okay, then it's fine.
but we'll check it. I'm not sure about it. I will let you know in the next session. Anything else? Let me ask one by one. Pawan?
No, I'm fine. I'm good.
Okay. So you will be going to come in the next session?
Yeah, sure, of course. I mean, next session, we also have some numericals, right? I think this week
Yeah, yeah.
also has some numericals, I guess.
Yeah. Nikita?
Yeah, I will be coming.
Any suggestion?
No, it looks good. It's
Okay.
fine.
Is it beneficial for you?
Yes, yes.
Okay. Kaushika?
Yes, sir.
Anything?
No, sir. I want to know, will this available in any online? Can we go through it again?
Yeah. It will be available in online on the same portal where there is a swim thing. You will there will be a tab, live
Okay.
interactive session. Then when you click there, you will be going to get it. So it will come
Okay.
in after 1 week around.
Okay,
Mostly.
sir. Sir, and then can you go to the last problem?
Okay. Yeah.
Actually, I am having one doubt. That number of particle, at last you did something, no? You put m cube in both the denominator
Actually,
and numerator.
yeah.
That
So
thing, it's little
we have
confusing for
started
me.
from here. So it's gram per centimeter cube density. So we did a mistake here. So we need to convert it into the meter cube because everything we are putting afterwards is in meter. So R we put here is in meter. So it is 5 into 10 to the minus 4 into 10 to the minus 2. That is meter. So other things are R, but we need to put it into the meter. But this thing will remain in centimeter cube. So we have a priori converted this centimeter cube to meter cube. So in order to do that, we have multiplied it by 10 to the power minus 6 meter cube.
Sir, that thing is fine, but in denominator you put 4 3 pi r cube meter cube,
This
no?
one.
This one. Why you put meter cube there?
Oh, okay. Sorry. So I wanted to say that it is, because it is,
It's not needed there, no?
it's not it. Yeah, it is not it.
Okay, sir.
Anything?
No, sir.
Okay. Rashmi? Rashmi,
Yeah, I'm there. All fine. I'll be there in the next session.
any suggestion?
Sir, as of now, I don't know like what to say. It's just the first session, and I am basically the purpose of joining this session is I'm working on metal nanoparticles green synthesis. So I'm trying to relate the learning basically.
Okay. So I forgot you are from where?
Mumbai University,
Okay.
Patkar College, yeah, Mumbai.
Dinesh? You are muted actually.
I think I'll be. I mean, the next sessions will be more technical. I think.
Yeah.
Right now, it's I think
Yeah, Brown
it's more
inputs
useful
and
for
angular
my.
inputs.
Yeah, it will be more intense.
Yeah. It will be
Okay.
going to be very difficult. This course is
That's fine.
although
Yeah,
though it's
difficulty is
8 week
good.
course, this course it's 8 week course, but it is a very difficult course.
Oh, okay. IIT Kanpur courses are pretty difficult.
No, this is not IIT
Yes.
Kanpur courses. It is from
Oh,
IIT Madras.
okay, but you are from Kanpur.
Yeah, I am taking it from Kanpur. So I am a TA from Kanpur.
Oh, okay, fine.
Yeah.
Okay, nice.
So any suggestion?
No, I mean it's really good. Yeah.
Okay. Thank you. Then we'll meet you all. Thank you for listening and
See you.
bearing.
Bye.
Okay. Bye.
Bye, guys. Bye.
Bye.
Right.
Bye.